All right, everyone. You all should be here and have done your roll call at this point. Good morning. Good morning. Welcome to Monday Chemistry Day 1. We sent out a memo earlier this week, last week rather, letting you know that tomorrow and the rest of the week will be manicuring and pedicuring taught here at the North School. So any of you cosmetology students or nail techs that are on the distance learning, if you wanted to come in and get practical hours here at the school and learn manicuring and pedicuring here in person, feel free to do so. But by doing so, you would need to be in school the entire 4 days at the location. I asked for you to respond to us to let us know if that's what your interests were. There are some of you that are deciding to stay on distance learning this week, which is cool. You should have already gotten your kind of agenda, the layout. Katie sent it out, I believe, on yesterday. We had kind of had a conversation with everybody on, in chat, whatnot, about agendas and things like that. Things have been very hectic and busy with opening the school and doing 2 and 3 and 5 things at one time. So it was asked that you guys just hold on and hang tight for the ride, and we will get there together. So we're going to try to be more proactive with getting your agendas so you know what is going on, and hopefully the night before, so you can better plan your days. Anyhow, we're still sticking to the same schedule pretty much, 9 to 11, 12 to 2, and 3 to 5 with various assignments. This week, and with today in particular, you should have already gotten your assignments. It's basically rewriting some of the note information. I'm going to be covering some of the chemistry information this first hour or so, and you have your assignments that have already been sent to you as well, where you're basically rewriting and re-juxtaposing the sheets. You're going to take the examples, it's going to correlate with the information that we're covering in the notes, and it will start to make more sense to you once you've taken a look at it, obviously. We go over the notes and the information, we talk about it, when you look at the examples of the diagrams that you're recreating, it will start to kind of make sense and some into your mind. Some of you may think, well, why can't I just print it out? Well, guys, printing it out doesn't do anything for your memory or your intellectual. You're just pressing a print button and getting ink all over some paper, and boom, you're done. That's like the shorthand version of things. And so we don't take shortcuts here at Baldwin Beauty Schools. We make you write things out. I applaud you if you have those ink and printer and paper and all that stuff at home. However, I do want to remind you that writing it out is what is required of you in order to send in this assignment. Remember, there are 6 hours that are possible today. In order for you to get all of these 6 hours, you will, of course, need to turn in your assignments by 5 o'clock p.m. to the bbsdistancelearning@gmail.com. Now, that it may be just a matter of you snapping a picture of your notes and what you've created and emailing that in. That's cool. Or scanning it if you have that ability as well. Okay. But these assignments are required for your completion. I'm sorry, I keep looking off because I'm here at the North School by myself, and it's just, when you're here by yourself, it's just kind of weird. You hear pops and sounds like, what was that? What was that? So even though I'm here in the office because I have work to do as well, I'm here teaching from the office. It's just kind of strange. So sorry if I keep looking off. It's just a little weird, a little creepy because nobody's here. I like to hear my name, Jeremy. Anyway, welcome, welcome, welcome. Happy Monday. I hope you guys had a relaxing weekend. It was short and sweet, let me tell you. Anyhow, all right, well, without further ado, we're going to get into our notes portion. Like I said, you should have already gotten the memo with what we're covering today. We're covering chemistry from 9 to 11 with me, and then there's a little assignment. You also should have gotten your assignment that's for the 12 to 2 portion as well, so you guys can get a little head start. Because I know some of you are like, I think somebody was saying, wow, we have a busy day, the next day we can maybe get a jump start. Yes, you can get a jump start on the assignments, but you can't send them in early necessarily because so keep them in the wings. So, it's a little bit of this and a little bit of that. Anyhow, without further ado, let's get started. Hey, Gracie, I know you're here taking roll. Welcome, welcome. All right. So, what I wanted to try to do is I got a bit of these notes printed out, which makes it easier. Some of these are going to have to be handwritten with me because I guess I broke the printer. I do that. I'm an expensive employee, y'all. All right, so first and foremost, some of you that English may be your second language, you guys, I'm going to try to take it slow enough that you can catch all this stuff. I know in the past you guys have kind of asked, well, can I type it up in the comments? And I may attempt to do some of that stuff with some of these terms that may be more difficult. I'm kind of thinking of some ways to make things simpler for you guys. But anyway, hope should be enough for you guys. You should be able to keep up still, okay? All right, so the first thing we're going to get into, you guys, is what we're talking about. Okay, what are we talking about? Chemistry. Chemistry. And what it is. Our topic is chemistry. Let's talk about what it is. What is chemistry? So you're going to be writing down these notes, you guys. Your little hands may be calloused by the end of this, but you should be writing this down. So pen and paper, people, pen and paper. Okay, chemistry. When you think of chemistry, I don't know what you guys think of. I know in our industry we tend to think of that you type the notes. Mercedes, that's perfectly fine if you want to type up the notes. That is perfectly fine with me. Yeah, I don't have a problem with that. That helps you keep up, you know. But when we think of chemistry, you guys, this is important in our industry for so many reasons. Some of you may have future plans for yourself. I don't know if many of you want to work in the salon and spa industry behind the chair or behind the manicure table or on the aesthetic, chair perhaps. But they're involved in every part of our industry. I mean, whether we're talking something simple as a shampoo and conditioning treatment, there's chemistry at work there on why the products work and do what they say they're going to do. There's a bit of safety involved with chemistry. We have to know what chemicals can be used safely on clients to actually achieve results, but also that we're creating benefits and not causing harm or detriment to our clients. We are licensed professionals, and we have sworn to uphold the safety of our community and the safety of our patrons by practicing proper protocols with these products. And so protocols were all developed through the study of chemicals and what their reactions are and what they do. There's been quackery in our industry for many years. From the beginning of times, you guys, people were like, take a teaspoon of this, a day, this wonderful elixir. Little did we know it was just alcohol getting people drunk and they felt better, huh? But it's just funny how things have evolved through the years, oftentimes barbers, you guys, back in the olden days, barber poles are red, white, and blue for a reason. It indicates that barbers were sought after like doctors. We would address wounds. We would bandage wounds. We would help to help heal people from blood infections and stuff, bloodletting and things, where we would actually drain lesions and things. We would apply leeches to sore wounds to try to help. We were thought of as doctors, and today we're still thought of hair doctors and skin doctors and nail masters. So we are entrusted with the public's trust, and so we are to act accordingly. So we got to follow those rules and regulations all the time. But chemistry is important because, like I said, you guys in your career, we get old. Miss Gracie will tell you she's been doing it for 44 years, right? And that takes a toll on our body. And so sometimes you may be rip roaring and going in the beginning and wanting to stand behind the chair for 12 and 15 hours a day and making that money. But eventually you may want to diversify your habits. Welcome, everybody. You may want to diversify your skills. I've talked to a lot of you estheticians before. You may want to develop your own skincare line. There's no reason why any of you cannot go and do something so fabulous for yourself. If you want to put your name on a bottle, all you have to do is learn a little bit about chemistry, get with chemists, and learn about products, what they do for the skin or what they do for the hands or the hair or the feet, whatever it is, and develop a product that actually is beneficial to the client. And you can market your own type of products. This is a country where we are founded on freedoms and liberties and things. Well, we were. Anyway, we won't get into that. But where we are supposed to be able to go out and grab life for ourselves and make something of it for us. We can be entrepreneurs and create business for ourselves. And so this information is really helpful in all aspects of our industry. So when we think of chemistry, what do you think of? What is chemistry to you? You just heard my spiel. But what is chemistry? What's the actual definition of chemistry? Okay. Chemistry is a science, y'all. It is an actual science Okay. Well, chemistry is a branch of science. It's a branch of science that helps with the identification. You guys already learned in talking with Kim in my class, a mixture of two compounds. There you go. More different. There you go. The way chemicals work and with and against each other. Exactly, Sam. Yes. Science of mixing chemicals. Yeah, that's right. But it's an actual science. We talked about the EPA when we were talking about disinfectants and things with salon ecology last week. The EPA is an environmental protection agency, but what did they do for us with our disinfectants? They registered chemicals, right? They had a registration number that showed that they had been tested and that they were safe for us to use. That's what's so important with chemicals. You know, you guys, things can get absorbed into your skin from using them. You know, so that's why it's important to wear gloves in our industry. People develop dermatitis and stuff. I know you ladies that do hair and you use hair bleach. How hard does that, or how does that burn your fingertips? You know, you ladies that are doing nails, the monomer and stuff, that liquid can absorb into your skin, and you can develop irritations over time through exposure. And so it's important to wear gloves and protect yourself because things do get absorbed. So the EPA has registered those disinfectants and stuff as being safe to use. And so it's through the science of chemicals that help the EPA register those things. So this is a branch of science, okay? The actual definition that you need to type it, Mercedes, right? Is this what you said you want to do? No, but it is the branch of science that deals with the identification of substances from which matter is composed. So different substances are composed of different, different substances are composed of different matter. So we're just trying to identify it, okay? So this is the branch of science that deals with the identification of substances from which matter is composed. I'm trying to break it down. The branch of science that deals with the identification. We're figuring out what it is, what makes up those substances that make up matter, okay? All matter is made up of substances. We're just trying to identify what they are. We want to know. So that's what chemistry is. The branch of science that deals with the identification of substances from which matter is composed. Not only that, there's more to that definition, you guys. There's more. But wait, there's more. Not only that, but it's also an investigation of their properties. Their properties. And the ways they interact. This is what Sam was talking about, how they mix and stuff. How they interact, combine, and even change and even become a new substance entirely. This is the investigation of their properties and the ways they interact, combine, change, and even become new substances. Entirely new substances. Okay. So that's a long definition there, Mercedes. I hope your keystrokes are covering it here. Investigation of their properties, excuse me, and the ways they interact, combine, and change, and even become new substances. All together, brand new. Change. Actually, it's change, but but the way they change. In essence, if you want to short term it, it is the composition and structure of matter. All substances, we're dealing with the composition, the structure of matter, what everything's made of, right? Sunshine and rainbows, right? And unicorns. No, we're going basic. We're going anatomical, you guys. We're going microscopic. We're getting in the magic school bus, right? And we're shrinking down. Yay. We're becoming microscopic. But it is the composition and structure of matter in general. That's what we're dealing with. That's what we're getting to the bottom of. That's what we want to find out with chemistry. And from there, we build up, right? So that's what chemistry is as a whole. Did you all get that? Okay. Now, when we talk about chemistry, okay, and chemicals and stuff, there are two types of chemistry that we typically deal with. Two types of chemistry. Two types of chemistry. It seems like everything we talk about, there's two types or two classifications or two groupings. You know, we were talking about with ecology, we had pathogenic and non-pathogenic, right? Well, with chemistry, it's kind of the same thing. There's two more groupings, right? There's two types of chemistry. Did y'all get that? Two types. I got two types of chemistry, right? One for the high, one for the low, one for the, yeah, you follow me? We got organic and inorganic. Okay, we're in Austin, Texas. We're in 2020. Everyone's wanting to eat healthier, live right, so we're all going with organic, right? Organic and inorganic. That's right, Lauren. Organic and inorganic. Which is kind of funny, like when I think about this, like if you're a vegan, right, you don't want to eat anything that was living, right? But yet you want to eat organic. I don't know. No, I'm just kidding. I guess you have, if you're a vegan, you really can't, I don't know. It makes me wonder, can you really truly be a vegan? Because organic was anything that was ever alive. Hippie healthy. I like that. Now we're not trying to throw shade, y'all. There's enough room in the world for everybody. I just eat cows. Oh no, I watched this little thing. What was it the other day on Netflix? I love meat. No, I can't know. His name is Minhaj, like kind of like Nicki Minaj. Oh gosh, it's a little thing like patriotic. It's oh man, I can't even remember the name of it. But he was talking about like how the meat producers of the world is kind of sad. There's like only 6 of them. Right, I am too, Victoria. That's weird. Curious on how synthetic meat will fall into vegan philosophy. Yeah, I know, right? No, but watching that thing was talking about how the meat producers are like there's only 6 companies, and that when the whole coronavirus hit, that one of the companies, you know, they had to shut down. So all the animals that were supposed to go to slaughter, they just wanted to throw them away because the time of the place was closed, the animals got too big, and we're going to be too big to still harvest. I don't know. It's just sad. Our world is strange. It really is. Capitalism and all this, it's strange. Makes me sad. Synthetic meat, I know, right? Grow it in a petri dish. But there's organic and inorganic chemistry, okay? What's organic chemistry? I'll tell you. Organic chemistry, okay, when we think of organic, it contains and is the study of carbon. Okay, when we're talking about organic chemistry, we're studying carbon, things that have carbon in them. Carbon or carbon atoms that are present. Okay, everything living Thank you, Kelly. I don't claim to be the most knowledgeable, you know. I like to laugh and joke around. Veganism is not eating foods that exploit and okay. It's not, plants don't count on an organic. Okay, plants is used to describe whether or not synthetic pesticides. Okay. I love to be educated and I love to talk about things, you know, when I don't know. So I'm open to all. If I need to be corrected, you guys, I don't have a problem with it at all. So I love that you guys teach me, you know. So that's what it's about. That's how people grow and become, you know, more educated and we rise. We what do you call that? We aspire to be more, right? Anyway, organic chemistry. When we talk about organic chemistry, we're studying anything that was ever alive, and things that were alive contain carbon atoms. Okay, so organic, containing and is the study of carbon atoms that are present. Okay, they're present like all plants and animals. Okay, referring to all living things. Anything that ever was alive or is alive has carbon. Okay. Okay. So anything that ever was alive or is alive contains carbon. So that's what we're talking about with organic chemistry. Now there's a side note with organic chemistry. Note, this branch of chemistry is known to be safe and or natural. Okay. It is important to know that organic substances are flammable and can burn. And they're not considered to be soluble, where they cannot be dissolved in water. So with organic chemistry, this branch of chemistry is known to be safe and or natural. Okay. It is important to know that organic substances are flammable and can burn. They are not soluble, meaning they cannot be dissolved in water. Water. Jersey accent, water. This branch of chemistry is known to be safe and or natural. It is important to know that organic substances are flammable and can burn. They are not soluble or dissolvable in water. Okay, I know that was a big chunk to write down. Okay. My printer stopped working, so some of this is going to be handwritten now, okay? So bear with me. All right, when we talk about organic matter, there's some examples of things that are considered organic matter. One example of organic matter, okay? So we got examples of organic matter. Examples of organic matter. A big one that you may not realize or may not think about daily if you try to live your life, we have gasoline or petroleum. Gasoline or petrol or petroleum, whatever you want to call it. Gasoline is an example of organic matter. Gasoline or petroleum. Why is gasoline or petroleum considered natural? Why? Or organic? Why is it not now? I'm sorry, not natural. Why is it considered organic? Tell me in the chat. I want to see it. Why is gasoline or petroleum considered organic? Good. That's a good one. That's right, because it is flammable. Yep. That's right. It does have carbon. That's right. Natural substances come from the ground. Yeah. It's dead dinosaurs not vegan. There you go, Kelly. Flammable. Yeah, would be a good reason. Yeah. Comes from the earth. Carbon. That's right. That's right. It's not soluble. That's true. That is not soluble. They're very good, Mary Helen. It's not soluble. Comes from the ground. Sure. But gasoline or petroleum is actually, that's right, it contains carbon. It's actually made from natural gas and oil. So I'm going to go ahead and type this down here because like I said, it's made from natural gas and oil. It's been processed, right? It's been processed, but it is still considered organic because it's composed of those things that have carbon, like we said, dinosaurs and things like that. So it is considered organic matter. Another item or things, I shouldn't say item because there's plenty of them. These are not always our friends either. Plastics and fabrics. That polyester, right? Or that microfiber. Microfiber is still popular these days, right? It's just plastic. But it's still considered organic matter. Plastics and fabrics are also considered organic. Plastics and fabrics. Are considered organic matter. Yep. Now, why would you think that plastics and fabrics would be considered organic? Okay. Plastics and fabric. There's all kinds of different fabrics. What I was referring to, the polyester, that's kind of a fabric that's made up of plastic, essentially. But there's other fabrics out there like cotton, right? My dad hauls all of these things. I'm going to text him. He's an organic hauler. That's right. Cotton would be an example for something. Cotton is considered organic because it was a plant, right? Has carbon. Okay. Plastic, we don't think of that as being organic, but what makes plastic? We were just talking about gasoline being made up of what? Gasoline or petroleum being made up of natural gas and oil. Silk, right? That's natural. Wool has come from an animal. That's right. Well, leather isn't a fabric, but leather, it's kind of gross. But even polyester and rayon and things like that, they are still considered organic because even if it's plastic, plastic is considered organic because it is made up of the same petroleum products. Petroleum, oil. Even though we think of plastic as being bad, and it really is because it doesn't biodegrade, and we've got a mass of it in the oceans and turtles with it up their nose that makes us cry, but yet we still go and get our straws with our to-go orders. Yeah. I know there's those metal straws and bamboo straws and all that, which are helpful, but we really got to stop wasting, people. Oh my gosh, the world. Our poor children. But plastic and fabrics are considered organic because they can be burned as well. That's cool, Molly. As long as we know that you're here, girlfriend. I get your Mercedes. I appreciate you guys still being here and hanging out. But they're still considered organic because they can be burned as well. They can be burned. And they're made of things with carbon. It was snowing microplastics. Are you serious, Victoria? That's sad. Microplastics. Oh my gosh. I just see those little birdies, you know, like all little carcasses laying there with plastic full in them. It's just sad. Oh. I was watching another documentary about like plastics and Bakelite and all that. We're just, I know, Chandler, that's what I'm saying too. What? It's crazy. So a third item that is considered organic matter. Yep, plastics don't dissolve. They just break down into microparticles and get picked up by your weather. Wow. It's crazy. Okay, so we have gasoline as an example of organic matter. Plastic and fabrics are examples. Then we have pesticides and fertilizer. Pesticides and fertilizers. My marker, you know, my marker started running out too. Can y'all read that well enough? Pesticides and fertilizers. Pesticides and fertilizers. One does the killing and one tries to encourage growth, right? Pesticides try to kill those pesky pests, and fertilizers trying to bring everything to life. Pesticides and fertilizer are considered organic because of what they are made of. They're typically made of animal matter, compost waste, and sewage, believe it or not. Do y'all remember that? Here we had the Dillo dirt put on at ACL. I was there that year, y'all. That was disgusting. That neem oil is really popular, I hear, Victoria. Everybody's loving on that. But yeah, that Dillo dirt was like a form of like the solid waste they take from the water treatment plants, and they like composted it and made it into fertilizer. And ACL the year before was the Dust Bowl because it was all dry and there wasn't any grass. And so, everyone's wearing dust masks that year. Well, the very following year, they didn't want that. So then they went and fertilized everything and laid out some, like grass seed, but they did it a little too soon. And what happened is it ended up raining a lot that year. And so the Dillo dirt expanded and became like a sloshy, like frothy, muddy mess. And what was gross about it, I know, yeah, they're organic. But what's so gross about it is people were sliding in it, like having fun in it, and they didn't know what it was. It was all poop. Yeah, gross. Yes, it was horrible. And then, I'm a freak anyway. My skin's real sensitive. I'm like, ooh, got on my leg. I started itching and everything else. Yeah, so poor little city of Austin. They've had their little ups and downs trying to get, find out what works. So yes, pesticides are considered organic matter. Antibiotics are considered organic matter. Grass and trees are considered organic matter. And also, I don't know if you can see it on the very bottom there, oils, soaps, and detergents. Yeah, antibiotics, they were made from something living, right? Grass and trees are kind of obvious because they're alive right now. But oils, soaps, and detergents Like good old fashioned lye soap and stuff like that, it had animal fat in it. It is hard to get out of the water. You know, Mallory, and what's so crazy is that our tendency is to flush all of our waste, down our pipes. That's why they're real big time now on medications and stuff, because medications are getting flushed, like old medicines, and that's hard to get out of the water too. And so, we're talking about like how our kids seem to be growing up more quickly. You wonder, is it because all the hormones from like, the pills that we take and stuff? I don't know. It's just crazy. I don't know. Yeah. That's why they say though, Mallory, like matter exists. Yeah, we are, Reagan, we are. But they say matter doesn't ever go away. It just changes its form, you know? Yeah, it is. We're like little experiments, I think, all our life. But you know how they feed those chickens like stuff to fatten them up and everything, and they can't even walk, and then the bovine. It's so funny on milk. They're like saying our farmers profess to not use these hormones, but underneath that it says these hormones are not proven to cause any problems. Though they're like kind of like, yeah, they say they don't use them, but even if they did, they don't cause any problems. I know it is, Mary Helen. Yeah. Yeah. That's true. They do lie. They do lie. But it's important, I guess, that we do what we can. Try not to get yourself like psyched out. We're like, oh my god, I can't make a difference with all this going against me. You just got to do your best every day that we can. Just kind of make the best decisions that we can. Don't try to wear yourself out and be down on yourself. Just do what you can. I know it's easy to get mad at other people. Why can't you do it too? And I felt that with you before too. But we just got to try to make small changes. While we're here. But yeah, so antibiotics, grass, trees, oils, soaps, and detergents. Those are all great examples of organic compounds or organic matter. The Berkey filter, I heard that. Yeah, Berkey filter works great. hmm She is your friend. Let's not be toxic. Let's do our part and help to encourage others. That's true. All right, so those were one type. Remember, because we know what chemistry is, right? It's a study of living matter, essentially, or uh, I'm sorry, chemistry is the study of the identifications of substances that make up all matter, and we're trying to classify them. And there are typically two classifications: organic and or inorganic. And we talked about organic was anything containing carbon that ever was alive. And give you some examples of organic. So if organic was anything that was alive, then we're going to talk about inorganic. Okay. With inorganic, they do not contain any carbon. My writing, this marker was a little rough here. So inorganic is anything that does not contain carbon, would not contain carbon. But contain hydrogen. They don't contain carbon, but they would contain hydrogen. These buggers were never alive, any shape or form. So in inorganic, do not contain any carbon, but contain hydrogen. And they never were alive. Never were alive. Okay. Some examples of inorganic. When I think of inorganic, a good way to think of something that is inorganic, they would not burn. These things that I'm going to mention that are inorganic would not burn. An example would be minerals and metals, like lead, iodine. Minerals or metals. Like lead or iodine, perhaps, would not burn. Rocks, there you go. Pure water. Pure water. Why do I say pure? Because things can get dissolved in water sometimes. But nothing living can truly get dissolved in there, right? Not carbon. But things can be held within water, you know. But when we're talking about pure water itself, it was never alive. It may help things stay alive. It may help bring things to life. It contains hydrogen, right? H2O, 2 hydrogen, 1 oxygen. Crystals, there you go. Clean air and glass. Clean air and glass. All right, so now we talked about what chemistry is, right? The two types, inorganic and organic. We talked about what organic things are and then what inorganic things are. But we were talking about these things coming together to form matter. What is matter? Matter is anything. Matter can refer to anything that occupies space. Matter is anything takes up space. It has a mass or a weight. Things that we can touch, smell, and see even. Okay? Anything that takes up space, it has a mass or a weight, or even a volume, something that you can touch, smell, or see. Everything exists and is said to either be matter or energy. Like I said, everything exists. It doesn't ever go away. It just changes form. For instance, trash that we burn, it just simply becomes carbon dust. But it's still here. That's why we try to recycle. Okay? We try to repurpose, recycle, because it doesn't go anywhere. We just try to make sure that we give it as much life as possible before we try to toss it away. Yeah, I like that. You're a waste of matter. I love those memes on Facebook too, where they talk about how people have so many butter containers in their house, and you open it up and it's never butter. That's kind of how it is, in my place. I try to use all those containers, because they come to you in those containers that you'll normally toss, and it's like give them new life. Use them for your leftovers to take to school at your lunch break, right? Reuse them. I don't know if I could ever train myself to remember. I can barely remember our bags to take to the grocery store, let alone try to remember to take containers to like a store that you fill in bulk items in containers. Do you reuse everything, Mary Helen? Well, I'm proud of you if you do. Do any of y'all shop at those places where they give you everything in bulk and you just bring your own containers? That'd be hard for me to remember. Like I said, I can't even remember my dang bags. I forgot those. And then it seems like anymore, like some of the stores are offering plastic bags again. Like, what happened to that? Where did that ordinance go? Oh, good. Oh, there you go, Victoria. Yeah. I know. That's what I'm saying. Forget my bags too. Sprouts uses their old boxes instead of using bags. That's a good idea. And every single glass jar I've ever received. Something about glass. Glass is fun to keep. Well, that's good. Yeah. Anything that we can do to help you guys. Yeah. When we talk about matter, like I was saying, that matter doesn't go away; it just changes form, perhaps. Well, when we talk about forms, there are three forms we're going to identify. There are three forms that matter takes on. Three forms. Okay. What are the three forms, you guys? What are the three forms of matter? I know you can guess them. Yes, yes, Hercules, Hercules, solid, liquid, gas. You guys are doing great. Solid, liquid, gas, for sure. Now, some things maybe I think there's all the rage on people are talking about that liquid. What is it? They make it out of like cornstarch and something where it's like has properties of being a solid, but then it turns liquid really quickly. Things can be hybrids, but for the most part, there are three forms: solids, liquids, and gases. You were so right, you guys. Solids, liquids, and gases. Remember what I was talking about, things that we can touch, smell, and see. It's funny because gases, you can't always see them, but you can smell them, right? Silent but deadly. You can't hear them. Liquid, you can hear liquid when it falls. You may not always see it, though, huh? Right? Solids, okay? Three forms: solid, liquids, and gases. Oobleck, that's what it was. Yeah, no, that's right, that's right. That's what it was. I couldn't, that's a strange word, Kelly. Oh, by the way, Gracie, Majestic Unitard is Kelly Rush. I think you know that. I don't know if you, I'm sure she got that, but I just wanted to throw that out there. Yeah, Oobleck, I couldn't think of what that was. Plasma? Yeah, I wonder if everybody was making those damn, you see it all the time where they're doing borax and glue and something. Slime. That's right, silent but deadly, Reagan. Oobleck is that mixture of water and cornstarch, is it, Kelly? It's like cornstarch and water or something where it's like if you try to apply pressure to it quickly, it holds up like a solid, like you can walk on water, but then when you let it fall, it... Okay, you got it, Gracie? Okay, cool. Yeah, oobleck. I don't know exactly what it is. Kelly might be able to tell you, but I thought it was like cornstarch and water and something. I don't know. Now slime is just weird too. it's got properties of the different matters. It's part liquid, it's part solid. I don't know about gaseous, but yeah. So when we talk about physical properties, when we talk about the properties of these things, okay, the three forms are solids, liquids, and gases. We talked about them having a shape. So something that is solid might have a shape, whereas something liquid would not have a shape. Yeah, cornstarch and water, anything that is two states at once is non-Newtonian fluid. Yeah, okay. Yeah. But yeah, when we talk about solids, liquids, and gases, we're talking about matter is anything that takes up space, has mass or weight. Well, the thing with gases, though, gases would not necessarily have weight, but they would have volume. You can measure the volume. Like a balloon would contain a gas, and you can measure its volume that way. Pounds per square inch kind of rating, you know, like your tires, the air in your tires. We measure the pressure, how much is contained within an area. So that's kind of, you know, the different ways we do it. Like liquids might be measured in volume or, you know, how much they contain. It doesn't necessarily have a shape. It takes the shape of whatever it's contained in. A solid, you know, has its mass, its shape, you know. A liquid takes on the shape of whatever it's been poured into, and we're measuring its volume. And a gas, it also is the same. We're measuring it based on its volume as well. And it takes on the shape of whatever it's contained in. So yeah. Now, when we talk about the properties, okay, when we talk about properties of matter, I'm going to have to write this up for you, okay? Properties of matter. There are going to be two. There's going to be we're talking about the properties of matter. There's going to be two properties that when we consider. We're going to talk about the physical properties. Oh, sorry. The physical properties of matter and also the chemical properties of matter. So let's first denote physical properties. What would the physical properties of matter look like? What would they be? Tell me in chat, what would physical properties be? List some examples. Maybe it's color. Color is something we can see, right? Shape, right? Texture. Your hand is cramping, Olivia. Hang in there, girl. Maybe I need to get like my girl Mercedes and get some sticky keys. No, I'm just kidding. Density, perhaps. Also, what about this? The temperature at which it freezes, or the temperature at which it boils, would be a physical property. Your fingertips hurt? Oh, now Mercedes. Oh my God. She's got jokes, y'all. She's funny. Your physical properties would be also the temperature at which it freezes or boils. Okay. That's right. It's volume. That's right. Exactly. Okay. So now let's talk about chemical. So all those, make sure you get those down. All those were right. You were giving me with the physical. Now the chemical properties would be its reactivity. Its pH level, perhaps. Its combustibility. How quickly does it burn? Like, what was that Usher song? Let it burn, let it burn, let it burn. I got a chick on the side and got two on the way. These are my confessions. Flammability, that's right. Toxicity, I like that. But it's reactivity, or it's reactivity with water. Those chemical trucks that haul stuff, they've got those codes. Let people know about their flammability. You know, like if they're hauling some diesel, you know, if they got into a car accident, everyone needs to know, oh my God, this thing can blow. Okay, that's fine, Jen. Just do your homework, girl. Okay. So heat, combustion, reactivity with water, pH level, all that are your chemical properties. Okay. Now we've already hit on this. So I'm just going to re-hit. Okay. Now when we talk about I'm just going to hit on this, but I don't know that you need it. But you know, like if we talk about the forms of matter, solid, liquid, and gases, you all, I really shouldn't have to say this. Oh wow, yeah, that'd be scary, Validia. But if we talk about the properties, we're talking about physical and chemical properties. We're talking about the physical properties or examples of solids, liquids, and gases. Solids are going to be things that you touch, like the desk I'm touching. People are solid, right? Unless you drop the hood. They have shape and volume. Then, of course, liquids would be examples of like waters and lotions and astringents and things that we use. And gases would be stuff that we breathe or inhale or that is within air. Okay. Air we breathe. So solids, liquids, and gases. All right, now we're going to get into elements. And atoms. Give me just a second here. All right, when we talk about elements, we're going to talk about elements and atoms. Okay? Elements are the basic units of all matter. Okay? Elements and atoms. Elements are the basic units of all matter. They are simplest form of matter. If you broke it all the way down, simplest form of matter. There are around 90 different elements that are created chemically, that are chemically formed, that have properties of both chemical and physical properties. There are really over 105 known elements. But the ones that we deal with are cones, the cones elements, COHNS. You guys might remember when we went through trichology before, talking about the elements that make up hair, skin, nails, or make up protein, keratin. Cones elements. You guys should remember cones stands for carbon, oxygen, hydrogen, nitrogen, and sulfur. Okay? Those elements come together to form the protein that is known as keratin that is found all over the body. Hair, skin, and nails, all three are made of protein. That's why when hair gets damaged, we try to re-strengthen it with protein treatments. But we don't want to overdo that, right? Because we need water too for flexibility. Okay? But the cones elements. So elements are the basic unit of all matter in its simplest form. There are around 90 elements that are chemically formed, that have physical and chemical properties both. And there are about 105 total known elements. But the ones that we most are involved with are cones, COHNS, carbon, oxygen, hydrogen, nitrogen, and sulfur, the cones elements that make up protein. Yes. Now, an atom is even smaller than an element. Okay? When we talk about elements and atoms, yeah, sulfates are not the greatest. You want to stay away from those. They're overstripping, but we do have them in our chemical composition of hair, skin, and nails. So it's there. But yeah. So you do want to try to stay away from sulfates and phthalates and things like that. Okay, so when we talk about elements and atoms, element is the basic unit of all matter, but atoms are even tinier. Atoms make up the smallest particles of elements. So atoms make elements. So an atom is a particle that makes up elements which help to make all matter. Two or more atoms with the same element are called elemental molecules. Okay. I'm going to do this because my writing is so bad. Now, molecules, though, are made by joining two or more atoms chemically. That's right. There you go, Chloe. So here, can you guys see that up here? Is that better than my writing? I just worried that this was too small for y'all to see it, so I was rewriting it. I'm retyping it because I didn't like this. Can y'all see it? Okay, so up there at the top it says element, which is a basic unit of all matter. Okay. And I was telling you that there are basically 90 chemically formed elements that have both chemical and physical properties. An example were the Cone's elements: oxygen, carbon, hydrogen. Okay. Although there are over 105 known elements. Then we went into what atoms were. Atoms are even smaller than elements because atoms come together. Atoms composed of atoms, smaller particles of an element. Okay. Two or more atoms with the same element are called elemental molecules. Then, Chloe, you reiterated that molecules are made by joining two or more atoms chemically. Okay. Hydrogen and oxygen make water, H2O, right? H meaning hydrogen, 2 denoting that there are 2 atoms of hydrogen, and then 1 of oxygen. Makes water. Okay, did y'all get that? All right, I know we're running a little behind here, but I wanted to make sure I got to it all, okay? My printer was on the jam, and so I wanted to make sure that I got you all this stuff. I was trying to write it, but I feel like my writing's horrible. Now, when we talk about an element singularly, an element can come together with another element and form what is called as a compound. When we talk about compounds, compounds are made when 2 or more elements unite chemically. Okay? Compounds are created when 2 or more elements combine. Earth, wind, water, fire, go planet, right? No. Compounds are made when 2 or more elements unite chemically. Many types, but the 4 most important include the 4 most important types of compounds. Let's just list them here. Be a little easier for you to write. The 4 most common types of compounds. The first one are oxides. Oxides, an element that combines with oxygen. An example of an oxide would be carbon dioxide, CO2. 1 atom of carbon and 2 of oxygen. 2 oxygen gets together to form an oxide, so carbon dioxide. Carbon di means 2, dioxide. So those are oxides. So when any element combines with oxygen, it becomes an oxide. Then we have acids. These are compounds with hydrogen combined with nitrogen. And oxygen. That's mistyped. Acids are created compounds with hydrogen combined with nitrogen and oxygen. Examples of these Okay. Example would be litmus paper. Litmus paper that is used to measure pH levels. A reaction occurs when you stick a litmus paper in a solution. It changes colors based on a chemical's reactivity. It turns either a shade of green or blue or yellow to indicate its acidity or alkalinity. Now bases, okay, so acidity is when it's a compound is mixed with hydrogen combined with nitrogen and oxygen. Now bases are alkaline compounds that consist of hydrogen, metal, and oxygen. Okay, example of this would be sodium hydroxide. That creates soap and relaxers for the hair. Not to mention, do you know that stuff's in cigarettes too? So if any of y'all smoke, please stop, because they have sodium hydroxide in your cigarettes. And that is designed as a depilatory to remove hair. You're smoking that. Yes. And vaping, I don't know if that's any better. I don't know. Vapors are just more trendy now, I guess. So the four compounds: oxides, when anything mixes with oxygen; acids, when they mix with nitrogen and oxygen. Then we have bases, when they mix with hydrogen, metal, and oxygen. Then we have salts. A little closer. Salts. It's a reaction from an acid and a base together. Example would be salt or Epsom salt. That's what I thought, Kelly. I'm like, wow, the little hairs that you have you have hairs in your lungs anyway. I was like, ooh. Is that better, Lauren? Sorry, guys. Yeah, cilia. There you go, Vicky. Flagella is the snake-like tail. Cilia are the hair-like projections. Yes. Cilia. Did you get it, Lauren? Are you guys got it? I'm going to drop the paper. Now we're talking about mixtures. Mixtures. Well, Kelly, Kelly. I think that is that's not every man, because all right, so mixtures. Mixtures are created when two or more elements that combine physically rather than chemically. The mixture goes the mixture does not change their properties as they do in compounds. Okay? Mixtures, two or more elements that combine physically rather than chemically. The mixture does not change their properties as they do in compounds. An example is concrete. An example is concrete. Concrete is composed of sand and gravel and cement. The ingredients do not lose their properties. It's kind of blurry, Lauren. I'm sorry. You guys are doing great. Hang in there. We're almost done. How's those fingertips, Mercedes? You still there? Okay. Now let's talk about their properties. Okay, this is the last one. Properties of elements, compounds, and mixtures. Chemical compound and their physical mixtures. Chemical compounds are a combination of two or more atoms of different elements. Chemical compounds are combinations of two or more atoms of different elements that are mixed or united chemically. Mallory, where'd you go? You went on to another video. What happened? Examples of these would be hydrogen. It's a colorless, physical mixtures. So we had chemical mixtures where two or more atoms of different elements combine chemically or unite chemically, whereas physical mixtures are a combination of two or more substances united physically. Hydrogen, it is colorless, odorless. I don't know why is it so blurry? Colorless, odorless substance united physically. Okay. I'm sorry, I was down here. Colorless, odorless. Hold on 1 second. Sorry guys, my reading backward game is not on point today. Here we go. All right. So up at the top, we're talking about properties of elements, compounds, and mixtures, right? A chemical compound was a combination of two or more atoms of different elements united chemically. Then we had a physical mixture, which is a combination of two or more substances united physically. So here are their properties. The first one, we have hydrogen. Hydrogen is colorless, odorless, and tasteless. It's colorless, odorless, tasteless gas, and is the lightest element known to man, hydrogen. When it's in its elemental form, it by itself is colorless, odorless, and tasteless gas, and is the lightest element known. Then we have oxygen. Oxygen is the most abundant on Earth. Good to know, right? It's the most abundant on Earth and composes about 1/2 of the Earth's crust. Half of rock and 1/5 of the air and 90% of water. It's the most abundant element on Earth. It's about 1/2 the Earth's crust, half of rock. It only makes up 1/5 of the air. It's about 90% of the water. When it combines with other elements, these are called oxides to support combustion. Another element we have is nitrogen. It too is colorless and is a gas. Believe it or not, our air that we breathe is about 4/5 nitrogen. Nitrogen is colorless, gaseous element. It's about 4/5 of air, and it is also found in ammonia. Then we have air itself. Air makes up the Earth's atmosphere. It's colorless, odorless, and made up of 1 part oxygen and 4 parts nitrogen. It is essential to plant and animal life here on Earth. We got to have it. Then there's water. It's also one of the most abundant substances. It's about 75% of the Earth's surface, and it's about 65% of our body yaddy. So we've got to drink plenty of it, right? The body's cells require water to live. Water itself is a conductor of electricity. But distilled water is not a conductor of electricity because it doesn't have anything to help transmit through it. See, water has dissolved things in it. You know, obviously it's not pure. But distilled water, when it's boiled free of anything in it, it is not a very good conductor of electricity. Boiling it at 212 degrees will destroy most microbic life. And then we have hydrogen peroxide. We talked about hydrogen at the top of the page. Hydrogen peroxide, though, is the chemical compound that is hydrogen and oxygen, and is colorless. It is slightly acidic, and we use it in hair coloring to oxidize the tint applied to the hair or the skin or whatever we're coloring. Hydrogen peroxide can also be used as an antiseptic. to kill bacteria on the skin. It is considered organic matter. Oh, wait, hold on. Organic matter such as silk, hair, feathers, and nails are lightened by the use of hydrogen peroxide. That's cool, Victoria. Hot ice also exists. It's water that exists in extreme pressure and has a different density than cold ice. Wow. Not only hydrogen peroxide is used as an antiseptic, organic matter such as silk, hair, feathers, and nails are lightened by hydrogen peroxide. This is why hydrogen peroxide is used under the free edge of the nail to brighten it. So yeah, when y'all are doing manicures and the ladies are looking for those white, like these, see these, yeah? These white free edges of their nails, that's not French, that's natural. You use hydrogen peroxide under the edges and it helps to brighten. I'm kidding, my nails look bad, but still, they look kind of French. Ooh la la, wee wee, right? So those are the properties of elements, compounds, and mixtures. Kind of interesting information. Now, it may not be pertinent to you right now in the ways that you're servicing clients right now, but I tell you, it will come into play when you're using chemicals on the client's skin and on their hair. You need to be familiar with them, their safety. Okay? That's why, and also how their effectiveness. You know how many times y'all hear me about capping your developer? Cap your developer, cap your developer. It's just hydrogen peroxide gel, essentially, or mixture, and it will turn to water if you let it air out. It will turn to water. Well, we're done, Kelly. So there, you got it done already. It's been fun, you guys. Sorry it took me a little longer to get this stuff done. Don't forget your assignments are due at the end of the day by 5 p.m. Email them to bbsdistancelearning@gmail.com. Hope you had a little bit of fun. We'll definitely see you later on in the day. Do a final roll call for Miss Gracie, please. So final roll call. Woo, woo, woo.